Hello folks, welcome back to Java Object Oriented Programming, and we're going to discuss about method overloading. Method overloading is defining a method multiple times within the same class with a different or unique type signature. Type signature means method arguments. Here, when you are defining multiple times the same method, make sure every method definition have different or unique argument signature. Let us try to implement the method overloading in our rectangle use case. This is the rectangle class. In this rectangle class, we have setDimensions method with the two arguments. Now, let us define the same setDimensions method again with another signature. setDimensions. Now, this time I am providing only double single argument here. Only one argument. Now, this argument should be going into length and also breadth. How it is going to work now? setDimensions method I have called two times, but same name, different signatures. If I call the setDimensions method, whether which of the definition is executed, that is based on the arguments we provided. Let us go to the application and try to call those methods. We have created two objects of rectangle class. One is with 8.5 and 6.3, and the other one is 8.0 and 6.0. Now we will call r2.setDimensions. Two parameters will pass here, 5.6 and 7.8. Once again we'll call r2.setDimensions with 6.6. What will happen in each of the scenarios? In this case, two parameter version of the method executed, whereas this scenario, one parameter version of the method is executed. Okay, how it is going to happen? Out of the two different definitions we have provided, whenever we call the setDimensions with two parameters, this two parameter version of the method definition is executed. Instead, you pass one argument. This one argument version of the definition is called. So this is called overloading, defining two things but called only once based on the parameters we passed or based on the arguments we passed. Here one important point to be noted: based on the types of arguments, not the value. Here maybe when you are passing two parameters, the values may be 5.6, 7.8 or 8.3, 9.2. Two parameters you need to pass, and here one parameter, that may be any of the value, one parameter you are passing. So based on the types of arguments and based on the count of the arguments, a particular whether which method version of the definition is to be executed is resolved. Means here a link between method call, this is method call, and method definition, this is the method definition. A link between method call and method definition is established during the compile time based on the arguments we provided, arguments types we provided. Here you are calling the same method but executing different operations. Whether which operation is to be executed is resolved based on the types of the arguments we passed. So types resolved during the compile time, link established based on the types of arguments. So based on all these parameters, this is called linking during the compile time, or compile time linking, or static binding it is called. We are calling the same method, it is performing different operations, means changing from one to another form, which is called polymorphism. But this polymorphism is called static polymorphism or compile time polymorphism. In the similar way, how we have overloaded the member method of a class, even we can overload a constructor. Constructor overloading means defining a constructor multiple times with different type parameters. For example, here I have rectangle constructor with two parameters. Now I'm going to have the same rectangle constructor once again without any parameters. In this no parameter constructor, what we are going to do, length equals to 0 and breadth equals to 0 as well. Here, why should we define constructors multiple times? One is with parameters, the other one is without parameters. Let us observe. Here in the application, both of the rectangle objects, you are forced to pass parameters. What is the value for length? What is the value for breadth? But if you don't have parameters right now, but you want to pass the parameters after a moment, in that scenario, you should be allowed to call the constructor without parameters, something like this. Rectangle R3 equals to new rectangle of no parameters. In these first two scenarios, the parameter constructor of the rectangle class executed, whereas the last case, no parameter constructor is executed. In order to get more clarity and more visual understanding on this, let us write another simple display message in each of the constructor. Make sure this display messages should be removed by the time of you are going to give this class to production. Okay, so here sysout system.out.println inside of no parameter constructor. Okay, here system.out.println inside of two parameter constructor. Okay, then let us try to compile these programs, execute and see the output for more visual understanding. Java C, use rectangle.java, somewhere missing semicolon, set dimensions, one parameter, line number 13 in use rectangle.java, line number 13, yeah, here exactly. Save again, go back to command window and recompile. Right, successfully compiled. Now Java space use rectangle inside of two parameter constructor appear two times on the screen. We called fourth line and fifth line two parameter constructors, and in the sixth line we called no parameter constructor. The result of no parameter constructor invocation is this, and result of invocation of two parameter constructor is these two lines. Okay, so in this way we can overload member methods as well as constructor. So this is about overloading. Thank you for watching.